Bismillahirrahmanirrahim. Welcome to the first topic of chapter 2, data types. So the definition of data type is set of values together with a set of allowed operation. So meaning that, for example, we have a character data type. So the operation allowed for character data types, okay, we can manipulate it. For example, maybe we can alphabetize the character data types, but you cannot do a multiplication, subtraction on that kind of data. Okay, that's what does it mean by data type. Okay, set of value, okay, together with a set of allowed operations. Okay, so C++ has three type of data types. The first one is simple data types, structured data types, and pointers. So for the next few chapter, we only use simple data types. So structure, we'll start using in chapter 8, arrays. Okay, and and also for pointer, you should cover. Do you have a pointer subtopic? Let me see in your okay. So pointer, we will start use it in chapter in topic 10. Okay, pointers. Right. Okay, for simple data type, okay, we have three categories. The first one is integral, floating point, and also enumeration data types. But in this topic, we only discuss integral and floating point. Okay. So what does it mean by integral? Integral or integer is a number without a decimal point. Okay, so it can be further categorized into character, short, integer, so on and so forth. Okay, while floating point is to cater a decimal number. Enumeration is a user-defined data type. Okay, so we look at the first one, integral data type. Okay, so if, for example, if we declare our variable or constant as an integer, meaning that we ask memory allocate, okay, 4 bytes storage for our integer data types. Okay, so different compiler may allow different range of value. So meaning that, okay, this storage actually is our reference purpose only. Because this storage is depend on our compiler, so you can check. We can check our the real storage provided by the compiler by looking at your compiler documentation, or you also can check using a C++ program. So you can refer at the appendix F. Yeah. Right, so we will discuss furthermore about this kind of integral data type. Okay, so for integer data type, okay, this is the example of integer data types without a decimal point. Okay, so for positive integer do not require a plus symbol. Okay, it is enough for us to write like this. Okay, so comma cannot be used within an integer because we learned that previously comma are used only for separating item in a list. Okay? So if you put, for example, you have 1,500, so you cannot write 1, 500 because C++ will assume it contains of number 1 and also 500. Yeah? Not 1,500. The next integral data type is Boolean. So Boolean, it has values true and false. Okay, so we refer true and false as a logical values. Okay, Boolean true and false is kind of a reserved word. Okay? So the purpose of Boolean to manipulate logical expression. Okay, whether it is true or false. Next, we have a data type, character data type. Okay, so character is the smallest integral data type. Okay. If you look at the table, okay, compiler will allocate only 1 byte for character. Okay. It is used for single character, so meaning that whatever character that is that you have in your keyboard, we can represent it using a character. So So blank space is also a character. Okay. So you need to write it like this. Okay. Single quotes. Okay. Blank space and single quotes. Okay. Alright. So for character, remember it must close in a single quotes. Okay. So for example, like here, like this. Okay. So this is we define or we declare the variable as is a single character of capital E. Okay. Okay, so different character data sets exist. Okay, we have the well-known we have two types of data sets. Okay, the first one is ASCII and also we have ABCDIC. Okay, you can refer about ASCII and ABCDIC in appendix. In appendix, hold on, I can't remember. In appendix, let me check it first. Appendix. Okay, appendix C. Okay. So what does it mean by collating sequence? So for example, collating sequence mean when you want to compare between character, you want to compare between for example, uh, um, um, for example, hold on class. Collecting sequence means, okay, it is used when you want to compare a character. So for example, you want to compare between capital letter A and small letter a, so which is much smaller compared between these two. Okay, so we can capital letter A is represent in ASCII as 65, while a small letter of A is represented as appendix C. Let me check it first. Appendix C. Um, appendix C. Okay. Capital. Small letter A. The value is 97. Okay. So meaning that small letter A is much bigger than capital letter. Okay, because 97 is bigger than 65. Okay, okay, that is the collecting sequence. Okay, right. Good. This is for floating point data types. Okay. So C++ uses scientific notation to represent real numbers. Okay. So for example, okay, if we want to represent 75.924, okay, so we have here in C++, it represent like this. So E is stand for exponential. Okay, float, the compiler will allocate for bytes. Okay, we have two types of floating numbers, float and double. So float, we have 4 bytes, okay, while double bytes, meaning that double is more precise compared to float. Okay, so by default, C++ will assign your C++ program as a double. Okay, so that's why in your textbook, okay, it use double instead of float. Okay, but to optimize our memory location, if you need only uh, um, I mean the precision point between 6 to 7, so it is advised for us to use float. Okay, so what does it mean by minimum and maximum value of data types are system dependent? So this is similar like what we have discussed previously, meaning that we need to check our compiler because maximum and minimum value of data type is depends on our own compiler. Yeah? Okay, so this is a maximum of significant digits for float is 6 to 7, while for double, the significant digits is 15. Okay? So float, because it has a smaller uh, maximum number of significant digit compared to double. So float is referred as single precisions, while double is addressed as a double precisions. Yeah? Okay. This is our okay. This is your last line. Okay. So to declare a variable, we must specify its data type. Okay, we already learned what is data type. Okay, we have integral data type, for example, integer, boolean, character, and also floating numbers. Okay, this is the syntax rule to declare our variable. So first we need to define what is our data type and followed by an identifier. Okay, so for example, this is how we can declare our variable. So our variable name is counter and the data type is integer, meaning that we ask our compiler to allocate 4 bytes for this memory location, okay, that is named as a counter. Yeah. So how we can store a value in a variable? So we need to use a assignment statement. Okay. So for example, here we have expression. This is what we call it as assignment operator, and this is our variable that we have declared previously. So for example, here we allocate 0.05, okay, to the interest rate variable. So the data type of interest rate, since we have a decimal point here, meaning that we declare it as a float. Okay? Right, so that's all for our first topic in chapter 2, data types. Okay, thank you for watching.